Have you ever just been amazed at how your favorite streaming service knows exactly what movie you're in the mood for? Or how your bank can spot a weird charge on your card, like instantly? Well, the secret sauce behind all of that is a really powerful process called data mining. And today, we are going to pull back the curtain and demystify it. We live in a world that is just swimming in data. Every single day, we're generating this unbelievable amount of information. Just think about it for a second. Every click, every online purchase, every single social media post, it all just piles up into this gigantic mountain of raw data. But here's the thing, right? Just staring at a mountain of numbers is, well, pretty useless. The real trick and where the magic really happens is finding those incredible gems of knowledge that are hidden deep inside all that noise. So how on earth do we actually do it? Well, that's exactly where the mining part comes into play. So first things first, let's get a handle on what it is we're actually digging for. Okay, so at its very core, data mining is simply the procedure of pulling out useful information from these massive sets of data. And honestly, the name itself is the perfect analogy. We're not just looking at data, we are digging through it. We're sifting through these virtual mountains of raw material to find those incredibly valuable nuggets of actual knowledge. Now, here's something that's absolutely crucial to understand. Data mining isn't some magic button you just press and get an answer. Nope, it's actually one very, very important step in a much bigger journey. And this is where things can get a little confusing for people. The term data mining gets thrown around to describe the whole process, but technically it's just one piece of a bigger puzzle called KDD, which stands for Knowledge Discovery in Databases. Making this distinction is really, really important. The big picture goal, the whole shebang, is KDD. The goal is to discover knowledge. Data mining, on the other hand, is the specific tool you use in the middle of that process to extract the patterns that eventually lead you to that knowledge. So think of it like this. Data mining is the powerful engine, but KDD is the entire car. And here it is, the whole journey laid out from start to finish. You can see, way before you even get to the mining part, you have to do all this prep work. You've got to clean the data, integrate it, select the right parts, and transform it. And then, after the mining step finds some patterns, you're still not done. You have to evaluate those patterns and then present the knowledge in a useful way. Data mining is right there in the middle. It's the heart of the whole operation, but it completely depends on all the other steps before and after it. All right, so now that we know where data mining fits in the grand scheme of things, let's pop the hood and take a look inside that toolbox. What are some of the key algorithms that do all the heavy lifting? First up, we've got a real classic, the decision tree. And it's pretty much exactly what it sounds like. It's a kind of flowchart that helps you make a decision by asking a series of simple questions about the attributes in your data. So for example, say you want to predict if someone's going to buy a computer. The model might first ask, is their age under 30? If the answer is yes, it goes down one path. If it's no, it goes down another. Then it might ask, is their credit rating excellent? Each answer takes you down a different branch of the tree until you land on a final leaf node, a final decision, buy or don't buy. What's so great about this method is just how simple and intuitive it is to actually follow the logic. Another really powerful tool is used for something called clustering. Now, unlike decision trees, clustering isn't about predicting a specific outcome. It's all about grouping similar things together. Hierarchical clustering is a method that builds, well, a hierarchy of these clusters, either from the bottom up or from the top down. And the absolute best way to picture this is with something called a dendrogram. Just imagine an upside-down family tree, but for your data. At the very bottom, every single data point is its own little family. As you move up the chart, the most similar points get merged together into small clusters, and then those clusters get merged into bigger and bigger ones until at the very top, the root, everything belongs to one giant cluster. It's just a fantastic way to see the relationships in your data at every single level. So, as you can probably imagine, this whole journey to find knowledge, it's not always a walk in the park. There are some pretty significant challenges that data miners are up against every single day. These challenges usually fall into three big buckets. First, there's the question of how you actually do the mining and interact with the process. Second, you've got the sheer performance you need to pull it off. And third, you have to deal with all the wildly different kinds of data you run into. First off, data mining just can't be a set it and forget it kind of thing. It's not some magic black box. For it to really work well, it has to be interactive. You need a human expert in the loop who can guide the search, ask the right questions, and interpret the results. It's really a partnership between human intuition and the raw power of machine calculation. Okay, next up is performance. And this one is huge. When you're dealing with these absolutely massive databases, your algorithms have to be both super efficient and scalable. I mean, an algorithm that works beautifully on 1,000 data points might just completely crash and burn when you try to run it on a billion. And finally, the data itself is, well, it's messy. It's almost never in a nice, neat, tidy spreadsheet. It's coming from all over the place, in all these different formats. Some of it is structured, like in a database, but a lot of it is totally unstructured, like text from emails or images from a server. Just making sense of all that diversity is a massive challenge in itself. So, with all these challenges, you might be asking, why even bother? Why is this whole journey so incredibly important? Well, let's take a look at the payoff. This right here, this really gets to the heart of the transformation. On the left, you start with this chaotic mess of raw data. It's noisy, it's incomplete, it's basically unusable as it is. But after you run it through the KDD process, you end up with what's on the right: clear, actionable patterns and real knowledge that you can actually use to make smart decisions. And this knowledge has a profound impact on the real world. I mean, how can you predict the future value of a house? How do companies analyze our buying habits to create marketing that actually works? How do doctors identify risk factors for diseases? Or how do banks detect fraud in real time? The answer to all of these questions is data mining. The applications are truly everywhere you look. And that kind of brings us to our final thought for today. We've gotten so good at this, but you know what? We are really just scratching the surface. It really makes you wonder, in this world that's just overflowing with data, what truly transformative, world-changing knowledge is still out there, just waiting for us to find it?